Professor Rob Henning is a pharmacologist from the University of Groningen, and he explained to me how mimicking animals in hibernation might be the key to human health.
The principal thing we can learn from hibernators is how we can avoid organ damage. Hibernators cycle constantly during their hibernation season between periods of cooling, very deep cooling, 4 degrees, and full rewarming. They do that 30, 40 times per hibernation season, and if we would do something like this in humans, that would be a guaranteed recipe for disaster. Our organs would not survive this.
So why? What's going on? What's the damage it's causing?
Well, the principal point that causes damage is the rewarming phase. You go from a sort of standstill to a full operational system, and it means that the organism needs to start burning fuel. In our case, that's sugar and fat. And the problem is that during the rewarming phase, all the little processes that make up this burning are not very well aligned, and they make toxic compounds instead of the right compounds. These toxic compounds cause cellular damage. That's something that the hibernators apparently have overcome.
I mean, you said a minute ago, if humans were doing this, then it would cause us organ failure. So I'm assuming we're not. So why is this useful for us?
This mechanism I was referring to of making these noxious compounds, that's also operational in a lot of human diseases, including, for instance, Alzheimer's, high blood pressure, where we can use this. Diabetes is another one where we could very well use this trick in neutralizing these noxious compounds.
What's happening there, this noxious compound production, is something that we do anyway, but maybe to lesser extent than the animals.
The principal component of these noxious compounds are oxygen radicals. So these are very highly reactive oxygen types, which basically bind to all constituents of cells and basically destroy them. And that's why cells die. Now, they are made in vast quantities during this rewarming phase. We make them normally also a little bit, but in these diseases like diabetes, like high blood pressure, we also make an excess of these oxygen radicals, and these hibernators are very good at neutralizing them.
So you said that they've got some special technique which stops every hibernation from leading to organ damage. What's going on here?
One of the mechanisms we found out, and that is they produce a compound called hydrogen sulfide, or H2S. That's the stinky compound of rotten eggs, but they use it to neutralize these oxygen radicals. And above, the hydrogen oxide, which is made by the body itself, is also aligning this whole metabolic processes, so it not only neutralizes the oxygen radicals, but it also takes care that less of these are produced.
So this hydrogen sulfide, do we produce it ourselves as well?
Yes, every mammal produces this. We have a number of enzymes, so we could try to let's say, boost the enzymes to produce more. That's actually what the hibernators do during rewarming. But you could also give it from the outside, exogenous. The problem is that it is so smelly that nobody would really love to inhale it or eat it.
I can imagine. I'm just remembering when I've been to kind of volcanoes and particularly sulphurous places, it's horrendous.
Yes.
So how do you deal with that?
The hibernators have a special trick for it. They see to it that it is produced by the body in large quantities. And what we now discovered is a class of novel compounds that do exactly the same. So they boost the production of the hydrogen sulfide by the cells itself, and these higher levels can protect you from organ damage.
And you mentioned earlier some of the diseases that these oxygen-free radicals are involved in. Have you been able to show this work in any of these diseases?
We started off with cultured cells, but in the meantime we moved on to animal experiments, and we've tested these compounds in diabetic mice basically, and in chronic asthma. And in both of these models, the compounds show excellent results. So we're now currently at the level of animal experiments. And it's a whole procedure to take it ultimately to humans. But that's what we're currently looking at.
This sounds like some sort of miracle cure. Can that really be possible, that we could find something that's going to solve all of these different illnesses, diabetes, asthma, organ failure?
Well, a little word of warning here. We're not curing the disease. We're curing the consequences of the disease. And the consequence of this disease is this production of excess oxygen radicals that drives the disease forward, and that we can block. But the initiation of the disease, we do not address like this.